Okay, we are on, oops, let's scroll up about, there we go. Lesson 3A, solving two-step equations for Chapter 8, solving linear equations. So we just finished lessons 1 and 2, which dealt with solving one-step equations. In lesson 3, we are now going to move to simple two-step equations. Okay, so hopefully you're good with one step, so that way two steps not so bad. So on this first one, I guess technically this first question is like a hidden two-step equation, but anyways, we'll work with it. With the x, we have a negative x and we have a positive 12. So we want to get the positive 12 to the other side of the equation. The way that we do this is the opposite, so we're going to subtract 12. Okay, because that's a positive 12. So then we get negative x equals 40 take away 12, which is 28. So far, so good. I don't want to know what negative x is. I want to know what positive x is. And so the way that I can undo, this is kind of like a negative 1. So if you remember our sign rules, our integer sign rules, if you multiply or divide a negative by another negative, it will become a positive. So we are going to divide both of these by negative 1. So, and dividing by 1 doesn't impact the number, the digit that we're dealing with. So 28 divided by negative 1, or a positive divided by a negative, gives us a negative. 28 divided by 1 gives us negative 28. So x equals negative 28. Okay? And so 12 minus negative 28 equals 40. So 12 plus 28 equals 40. And it does. Yay! I keep kicking the stupid legs of the smartboard. It hurts. I'm going to move it. There. Hopefully Miss won't kill herself now with the stupid smartboard. All right, so looking at letter B, we have 3 times y equals 93. To get the y by itself, we need to do the opposite. So instead of multiplying by y, 3, we're going to divide by 3. 3 divided by 3 leaves us with 1y. 93 divided by 3 gives us 31. Next one, we have x plus 12 equals 35. So x is our variable. It's being added by 12. To isolate it, we need to do the opposite. And whatever we do on one side, we're going to do the same on the other. So then you get x plus 0 equals 35 take away 12, which is 23. Last one, our variable is n. It's being divided by 4. Opposite of divide by 4 is multiply by 4. So I'm going to multiply by 4 on both sides. 1n equals 28. Okay, so hopefully that was a nice, easy review for you. You were like, oh yeah, those are so easy. The first one might have been a little bit more complicated, but the rest should have been nice and easy for you. If not, see me in tutorials. Okay, so a couple things we need to keep in mind when we are isolating a variable. So if I say isolate, we're going to get it all by itself. Okay, it's going to be all alone. So sad. When we are isolating a variable, we use opposite operations. So we go reverse BEDMAS. So instead of going brackets, exponents, division, multiplication, adding, subtraction, no. We start with subtraction or addition, kind of whatever comes first as we go from left to right. Then we do multiplication or division, whatever comes first as we go left to right. And then exponents and brackets. We're not gonna be worrying about those. Okay, so we're gonna be doing backwards BEDMAS, getting rid of the constant before we get rid of the coefficients. Okay, so it's just kind of saying we're going to use opposite operations to get rid of the extras. So our first example of a two-step equation, and some of you might have seen some of these last year. Some of you haven't done two-step equations at all yet. So It'll be new for some of you. So the first thing we're going to do is we have 3x minus 2 equals 13. So x is the variable. We have 3 times x minus 2 equals 13. So it's being multiplied by 3 and it's being subtracted by 2. So working backwards through BEDMAS, we're going to deal with the subtract by 2 first. We are going to add 2. And notice that I'm only adding 2 once on each side of the equation. I'm not going plus 2, okay? I'm not adding 2 to everything. I'm adding 2 once on either side of the equation. So that way, minus 2 and plus 2 is going to equal 0. So then we get left with 3 times x equals 15. So we're just solving it kind of like it was 2 separate one-step equations that have been put together. So now we have a one-step that says 3 times x. We need to undo the times by 3 by doing the opposite. So we're going to divide by 3 on both sides. 3 divided by 3 leaves us with 1x equals 15 divided by 3, positive 5. So our possible solution is x equals 5 if we've solved everything correctly. We are going to check by substituting. So 3x minus 2 equals 13. Writing my equation down again. I'm going to replace x with the answer. So I'm going to replace x with 5. Notice that I substituted it in brackets. I didn't go 35 minus 2 equals 13. Okay, that's not what we want to do. So now when we are checking, we follow BEDMAS forwards. I know it's a bit confusing, but when we're solving a solution and checking a solution, we work forwards. When we're isolating a variable, we work backwards. So we're going to follow BEDMAS. So we have some multiplying. So we are going to multiply first. 15 minus 2 equals 13. And now I can subtract. 15 take away 2. 13 equals 13. Yay! X equals 5 is our solution. Oh, that was bad. Okay? 13 is not our solution. 13 is just showing how we check. So let's try these ones. Oh, too far. Okay, so looking at the first one, 23 equals 5t plus 3. So we've switched it around. The t's on the other side of the equation now. That's okay. We're still going to use opposite operations. So t is being multiplied by 5 and added by 3. So we're going to follow BEDMAS backwards to isolate the t. I'm going to get rid of any adding or subtracting first. We have plus 3. So again, I'm going to minus 3 just once on each side of my equal signs. So on the left-hand side, 23 take away 3 leaves me with 20. On the right-hand side, 5 times t plus 0 is just 5 times t. To get rid of times by 5, I'm going to do the opposite. We're going to divide by 5. And whatever I do on one side, I'm going to do the same on the other. So on the left-hand side, 20 divided by 5 gives me 4. On the right-hand side, 5 divided by 5 leaves me with 1t. So t equals 4 is my solution. I don't think I left you guys enough space to check, so we won't check these ones. The next one, 3w plus 20 equals negative 7. The w is being multiplied by 3, and it's being added by 20. So we need to work backwards from BEDMAS and deal with the addition first. So I'm going to subtract 20 on both sides of the equation. And I get 3 times w plus 0 equals negative 27. Right? You owe me $7 and then you owe me another $20. You owe me $27. I'll be expecting you to pay up tomorrow. We have a times by 3 that we need to undo. Opposite of multiplying by 3 is dividing by 3. So we do that on both sides. 3 divided by 3 gives us 1w. Negative 27 divided by positive 3 gives us a negative 9. Looking at the next one, there's a bunch of negatives. This one might be a little tricky. You guys can do it. We have negative 2 times f minus 3 equals 11. So we need to deal with a timesing by a negative 2 and A subtracting by 3. Working backwards through BEDMAS, we are going to deal with the subtraction first. So we're going to add 3 on both sides. So then we get negative 2 times F plus 0 equals 14. Now, at this stage, many of you would want to go plus 2, plus 2. That is not what we are going to do because it is not F take away 2. That's not what we're dealing with. We are dealing with a negative 2 times F. And the opposite of multiply is divide. So we are going to divide by the coefficient of negative 2 on both sides. This is the most common place where you guys will make mistakes. So please be very clear in your notes about this process. Negative 2 divided by negative 2 leaves us with 1F. Positive 14 divided by negative 2 gives us a negative 7. Okay, so I'm going to get you to solve this one by yourself, and I'm going to check it with you in class tomorrow. Okay, I know these notes have taken a little while. I'm going to show you a little bit more, and then we'll have lots of practice time in class, I promise. So, when we are checking or verifying a solution, remember that when we substitute in a value, we follow the correct order of operations. We are following BEDMAS. So, for these 4, I'm asking you to check if x equals negative 6 is the correct solution or not. Somebody solved it and said, you know what, these all have an answer of 6. We're going to check if they're right. I'm going to show you how to do a couple of them, and then you're going to do the rest on your own. So substituting into the first one, that means every time we see an x, we are going to replace it with a 6. So this x is going to become a 6. This x is going to become a 6. Okay, so looking at the first equation, 4, remember it's 4 times 6, not 46, plus 10 should equal 34. Following our order of operations, we need to multiply before we add. So 6 times 4 is 24, plus 10 should equal 34. 24 plus 10, this one works. So for this one, yes, x equals 6 is the correct solution. Looking at the second one, negative 10 plus 3 times 6 equals 28. So negative 10 plus 18, remember we multiply before we add, equals 28. Negative 10 plus 18, so this is the same as 18, take away 10, so that leaves us with 8 equals to 28. They are not equal, so x does not equal 6. This solution is not correct, or is incorrect. My English is not correct. There we go. Okay. I'm going to leave the last 2 for you to solve, and then we're going to check these again tomorrow. So I want you to figure out if they are the correct solution or not. Okay? Okay, and then the last, example 3, again, you are going to do these 2 yourself. You might want to look at example 1 for some help, and we can go over these together in class tomorrow and make sure that you are good to go.